Hi guys, so today we're talking about 4.6a types of energy. Now the way I like to remember the types of energy is MELTS, mechanical, electrical, light, thermal, and sound. Now there is no order, but it just helps me remember it, so hopefully it helps you. Alright, so first one is mechanical, the M. Now mechanical is the energy of movement. Whenever I move, when I walk, run, swim, right now, when I'm moving my arms, when I blink, I'm using mechanical energy. Whenever anything moves, it's using mechanical energy. Mechanical is the energy of movement. Pretty easy there. All right, now the E stands for electrical energy. We know this as electricity, pretty simple. Now we will go into a lot more detail about electrical energy in 4.6b and 4.6c, but just remember that electrical energy is the energy of electricity and circuits. And again, we'll talk more about that. All right, now L stands for light energy. This is the energy that allows us to see, okay? Now what's tricky about light energy is that it can do four different things. Now when light hits, say, glass, it does what we call transmit. That means it's going through. So if I stand at my window and I'm looking outside, I can see through the glass because light's transmitting. It's going through the window. Okay? Now the other one is absorb. Now absorb is when we see colors or we don't see black technically. So if right now I have blue in my lab coat. So this part right here, so this part in my lab coat is sucking up every color except blue. Now remember, when we see white light is all 7 colors. Roy G. Biv: red, orange, yellow, green, blue, indigo, and violet. Now this spot right here is sucking up every color except blue. It's pushing blue out. So we see blue because that's the only color that's leaving my shirt. Black, on the other hand, absorbs every color. So when you see black, you're actually not seeing any light because the shirt is sucking it up. Okay? When you see white, you're seeing every color bounce off that shirt because white light is all 7 colors. Okay? Now the other two can get tricky. We're talking about reflect and refract. Reflect would be the reflections. When I see myself in a mirror. Now here's what's crazy when I see reflection. When I see myself in a mirror, say the mirror's right here, I'm seeing light hit me, bounce off the mirror, and then go back to my eyes. There's a lot of bouncing in there. Yeah, because reflection is when light bounces off an object. Usually this is shiny, like in spoons, mirrors, we can see a reflection just because it's bouncing off. Now the other one is refract. Now refract is when light bends. Now sometimes we see this as when we see water or like a fish tank or something, like a pencil or a straw or something, and sometimes it looks like it's broken, it's bent in there. Well, this is because light slows down through different objects. Just like me. So we'll say I'm running, I'm a pretty fast runner. I can run really fast. But if I get in water and I try to run, I'm a whole lot slower. Water's more dense, it's thicker. I can't go as fast. So I slow down. Light does the same thing. When light goes through water or another materials, it slows down. And then when we see the light, when it slows down, to us it looks like it bends. Okay? That's refract. So again, it's transmit, goes through, absorbs, sucks up, reflect, bounce off, and refract is bent. Okay? All right, now thermal, or T, stands for energy of heat. Now we think of this, we talked a lot about water and water vapor before, right? So when I add thermal energy, I'm heating something up. When I add thermal energy to an ice cube, I'm melting it and turning it into a liquid. When I add thermal energy to a liquid, I'm turning it into a gas, water vapor. Then when I do the opposite, when I cool something, I'm taking away thermal energy. So when I'm adding thermal energy, I'm giving it heat. When I take away thermal energy, I'm cooling it off. Cool? Okay. And the last one, the S, stands for sound. Now this is the energy of vibrations. You could touch your neck when you talk and you could feel your vocal cords vibrating. When objects vibrate, they produce sound. Now here's what's kind of interesting. You can only hear me because when I speak, the air in between us is vibrating as well. If we go to outer space, there's no gas, there's nothing to vibrate, sound does not work. I could be right here yelling, ah, and you couldn't hear me because there's nothing there, nothing to vibrate, okay? So again, so we're talking about mechanical, electrical, light, thermal, and sound. These are the types of energies that we will be studying this year. Science.